In chapter 12F, question 2 of the textbook, we're looking at questions of finding the exact values of our trigonometric functions that are outside of the first quadrant. So notice in question 1, we were working with inside the first quadrant. Now we're outside the first quadrant. So consider the unit circle up here. What I've got is got a unit circle, and for the first quadrant alone, I've mapped all the exact values that we're going to use in this course. So at 0 radians, our cosine is or has an exact value of 1, and our sine has an exact value of 0. So notice that the horizontal displacement in this case, so I'll use an orange pen. So if we go across our horizontal displacement from here to here, it's at a maximum of 1, and the vertical displacement is at a minimum of 0. And going up to pi on 2, we see the opposite. So our maximum, or our cosine, our horizontal displacement, is at 0, and our vertical displacement's at a maximum of 1. So that's our sine value. Now, looking at everything in between, recall that we've got 3 exact values. So we've got pi on 6, which is the same as writing, let's say 30 degrees. And then we've got pi over 4, which is the same as writing, that's a bit thick. We've got pi over 4, which is the same as writing 45 degrees. And then we've got pi over 3, which is the same as writing 60 degrees. Now, this explained the values or the angles in the first quadrant of the unit circle and gave exact values for it. But notice that we've got 3 other quadrants. And the interesting thing about that is the symmetry as well of the unit circle. So notice that this first quadrant, so the first quadrant of the unit circle, if we grabbed it and then we flipped it about the y-axis, what we could actually do is we could see that we're going to have these exact values mirrored across the other side of the unit circle into quadrant 2. So they're mirrored on the exact other side. And because they're mirrored on the other side, what I can do is I can simply grab this pi over 6, the exact values for pi over 6, and I can dump them on this side of the unit circle here. But remember what I said about the positivity and negativity of the values or the functions. So we had this mnemonic, all stations to central, and what that meant was for all of our values, or all of our trig values in quadrant 1, they're going to have positive values. So everything coming out of sine, cosine, and tangent between a domain of 0 radians and pi on 2 radians, they're all going to be positive. But for quadrant 2, only the output of the sine function is going to be positive. So what that means is over here, our sine value is half. So that's going to stay positive, but our cosine value, that's going to become negative. So it's negative root 3 over 2. And we can do that for all of our values. So over here, this middle one, it's going to be root 2 over 2 and also root 2 over 2, but the cosine, the horizontal, is going to be negative. So it's negative root 2 over 2 and root 2 over 2. And then we've got 1 over 2 and root 3 over 2. And this half, that's going to become negative as well because that represents the output of cosine. Now the next question is, well, okay, I know the exact values, but what angle are they associated with? And to work out the angle they're associated with, let's grab another unit circle. I'll bring it down just for a bit of, no, I'll keep it up there so we can have a look at it. And what we find is that when we have our triangle, when we draw our triangle, notice for quadrant 1, we can draw an arbitrary line like that, touching the unit circle, bring it down. Notice that our theta is the interior, forms the interior angle within this triangle. So that's for quadrant 1, but consider for quadrant 2. We go to quadrant 2, and we draw our theta like such. So this represents quadrant 2. If we draw our theta, the theta value, it represents the exterior angle. And this interior angle, I'm going to call it phi. And what we found is that if we input theta into the calculator, it's going to give us a value, but what we want to know to mirror these exact values about the axis, what we need to know is the value of phi. So say 30 degrees, so for quadrant 1, 30 degrees or pi on 6, we have these exact values. To get those exact values, we're going to get, say, 30 degrees relative to this angle in here. But the question at hand is, we want to know what is the value of theta. So we don't want the interior angle of this triangle in the quadrant 2. We want the exterior to describe it in terms of this exact value. So the way in which we can do this is we look at from a geometric point of view, and we say for quadrant 1, the value of the angle is simply theta, the interior. But for quadrant 2, we have to look at it a little bit different. We know that if we added the interior angle, so if we added this phi and theta together, we're going to get pi radians. So we can say pi radians equals phi plus theta. And then to get the value here of, say, phi equals theta minus pi, or we could have theta equals phi minus pi, and that is radians. So if we wanted to find the exact value for this position here, what we can say is, we'll go, so for this red one here, we can go theta, I'll do it in red so it makes more sense, theta equals pi minus pi on 6, and what we find is that equals 5 pi over 6. So the exact value in red here is represented as 5 pi over 6, or if we convert that to degrees, what we find is it equals 150 degrees. Now similarly, doing it with the blue, or this midway point in the unit circle, we can go theta equals pi minus pi on 4, because this pi on 4 here, it's coming from this 45 degrees here, or pi on 4 radians there, and we want to map the angle that's on the quadrant 2 exact values. So we can say this theta is going to be, which one will it be? It will be 3 pi over 4. So 3 pi over 4. And finally, this purple one, if we did the exact same as well, and we said that it was equal to pi minus pi over 3, that simply works out to be 2 pi over 3. So I'll put that up there, 2 pi over 3. So instantly, what we're able to do is we're able to deduce the exact values on our unit circle by simply referencing all of our values that we know in quadrant 1 and then using the relationship that we found over here. Now quadrant 3 and quadrant 4, they're slightly different. So think about the triangles that are going to be drawn for quadrant 3 and quadrant 4. So in quadrant 3, our triangle is going to look like this, and we're going to have, get rid of these triangles up here so it's a little bit neater to see. We're going to have that exterior angle, which will be theta, is going to be between 3 pi over 2 and pi. So the interior is going to be looking like this. So the way in which we can describe the interior angle can be as simple as saying, and I'll get rid of these guys for a little bit more space. So having a look at this interior angle here, we can describe this interior angle phi as theta minus pi. So if we took pi radians away from theta, what we're left with is only this angle in here. So this would be the description of the interior angle for quadrant 3. And we could rearrange that such that if we want to know the exterior angle based on the interior, then we can go theta equals phi plus pi. And similarly over in the far right, bottom right, so quadrant 4, our angle of theta is going to be like this, and our interior angle like that. And this will be 2 pi, this is 0 radians. We can explain firstly we can explain theta can be explained as 2 pi minus the interior angle. And similarly, our interior angle phi can be explained as 2 pi minus theta. So we can interchange between these two forms to work out the interior angle and then work out the theta. So know the relationship between theta and that interior angle. So going back to the unit circle, if we wanted to calculate all of these exact values going down again, it's simply a matter of mirroring. So notice that in quadrant 1 and quadrant 2, if we wanted to map out quadrant 3 and quadrant 4, we just get the mirror image of what we've got over here, and we mirror it about the x-axis. So this purple line here, I'm going to mirror it downwards like that, and downwards like that. Then the blue line that goes midway between the two, like that and like that. And then finally my red line, so it's going to be like that and like that. Perfect. And filling in the values, so the red is representing a cosine of root 3 over 2 and then 1 over 2. But remember, the only values that are positive in quadrant 4 here are the cosines. So this sine value of half, that's negative. And over in quadrant 3, we're going to have negative root 3 over 2 and negative half, because only tangent's positive in quadrant 3. Now for the blue, we'll go quadrant 3 again. This is going to be negative root 2 over 2, then negative root 2 over 2 again. Quadrant 4, we're going to get positive root 2 over 2, and then negative root 2 over 2. And then finally, the purple one, it will be a half, positive a half, and then negative root 3 over 2. And then we're going to have negative a half and negative root 3 over 2. So recall that this second coordinate represents the vertical displacement. So notice that in these purple lines, on the vertical axis, it's always really far away from the x-axis. and for the first coordinate, so this cosine, it's closer to the y-axis. So using symmetry, we can deduce the exact values going around the circle, and then using our relationship of the interior angle of the triangle formed by the unit circle and the theta, so the angle of the line as it's swept about the unit circle, we can deduce the angles going around that are associated with these particular numbers. So on one note, we've got this beautiful table here. So you can reference this table here to get the exact values rather than these little bit messy diagrams. But let's do one or two examples to just reinforce the understanding of what we've learned here. So if we've got, say, cosine of 3 pi over 4, and we want to know the exact value for that, we'll firstly notice that 3 pi on 4, what quadrant is that in? So what quadrant is 3 pi on 4 in? Well, if I draw a little diagram here of a unit circle and go around like this, and this is 0, this is, put the arrowheads on it, this is 2 pi, this is pi, this is 3 pi on 2, and this is 2 pi. Well, 3 pi on 4, that's going to be less than pi, but greater than 2 pi. So this angle is somewhere in here, so quadrant 2. And what do we know about quadrant 2? Well, we've got all stations to central. So what we know is that only our sine values is positive, and our cosine, the output's going to be not positive but negative. So we're expecting a negative value. Now the next question is, well, okay, if this is theta, so theta equals 3 pi on 4, and theta being the exterior angle as seen over here, then what's our interior angle? So what's our interior? Well, our interior angle is going to be pi minus theta. So to work out the interior angle, we're going to get phi equals pi minus 3 pi over 4, and this will become 4 pi over 4 minus 3 pi over 4, and that will be pi over 4. So our interior angle is pi over 4. So what this tells us is the triangle that we'd see in quadrant 1, and that's got a unit value of 1. So the question is, because it's cosine, what's this value x there? So the way in which we can work this out is we know that pi over 4 has an exact value. So what we can do is we can go up to our beautiful triangle here, look for pi on 4, which is this guy up here, and then we can grab the cosine, so that one there. So it's root 2 over 2. So what I can say is, firstly, I can just dump root 2 over 2 there, and remember, we're expecting a negative value, so I'll simply put a negative in front. So this would be the exact value for cosine of 3 pi over 4, and it is negative root 2 over 2. So that would be an example of, or the logic behind how we get the exact values for angles outside of quadrant 1 of our unit circle.